Good morning, friends. In second year PSC, so far we learned two chapters. One is electrostatics, and second one is electric potential. But today we will learn one more topic, namely current electricity, which is very important in second PUC. The weightage of this chapter is nearly more than 10 marks. From this chapter, one 5 marks problem will come, 5 marks essay question, and 3 marks short answer, and 2 marks question, and 1 mark question. So total, anyhow, you can get more than 10 marks from this topic. Now, today in this class, we will learn the following concepts. What is the meaning of current electricity? What is the meaning of electric current? How the electric current is passing through the conductors, Ohm's law, and factors on which resistance depends. These concepts we will learn today. Now see, in electrostatics, we already know the charges are at rest. Now, the charges we can produce by either frictional method or induction method. But here, in this concept, we will learn how the charges are moving, how it causing the electric current. Now see here, I will draw on the simple diagram, then we can see the electric current very easily. See, here I am taking two conductors. This is conductor 1, this is conductor 2. Both the conductors are placed on insulating stands. Now, the first conductor as well as second conductor, it is charged, and the potential, particular potential is given. Now, let us suppose the first potential value is, first conductor potential is 4 volts, and the second conductor potential is 2 volts. Though both the conductors are very close to each other, but the charges cannot flow from one body to another body because the surrounding air is an insulator. There is no physical contact between these two conductors. Suppose if these two conductors are connected by a metallic wire, at this condition, the charges where the first body the potential is higher, from that body the charges are flowing from the first body to second body, because there is a potential difference is there between first body and second body. Because of this potential difference is causing charges to flow from high potential body to low potential body. Suppose both the bodies are at same potential, that is 2 volts, and here also 2 volts. At this condition, there is no flow of charges from one body to another body. Here, because both the bodies are at the same potential, so that is the reason the charges cannot flow. But here, you have to know one important condition. If the charges, if they are flowing from one region to another region, means definitely there must be a potential difference between those two bodies. Otherwise, the charges cannot flow. So finally, from this simple concept, we can know that the potential difference is causing the charges to flow from one point to another point. So this net flow of charges we call it as a electric current. Now, after this one, we see the definition of electric current. What is the meaning of electric current? The electric current is nothing but suppose if the charges are studied through any cross section of the conductor, the charges are studied through any cross section of the conductor in a particular time interval, then that charges per unit time is nothing but electric current. Now, I is equal to Q by T. Now, what is the SI unit? Its SI unit is ampere. Its SI unit is ampere, or simply its symbol is A. And define ampere. Suppose in a conductor, 1 coulomb of charge is passing through any cross section of the conductor in a time interval of 1 second, then that current is said to be 1 ampere. So once again, I'm recalling, 1 coulomb of charge is passing through any cross section of the conductor in a time interval of 1 second, then the current is said to be 1 ampere. Next, the later we see how this electric current is passing through conductors. See, we already know the substance can be classified into 3 types. That is solids, liquids, and gases. How this electric current is passing through the solids, liquids, and gases, which are responsible to carry this electric current through this substance. Now, especially in solids, if you consider the metals where the number of availability of free electrons are more, so those are responsible for conduction of this current in this solids. Whereas liquids are concerned where the ions are responsible, positive ions as well as negative ions. Whereas gases are concerned, in gases also only ions are responsible to pass the electric current through these conductors. Now, in a conductor, how these free electrons are behaving in the presence of electric field, in the absence of electric field, now we will see. See, here I am taking one conductor. Now here, external electric field is 0. Now, if there is no electric field, in such a condition, if the conductor is placed in the electric field, what is happening? If the electric field is absent, the number of free electrons are moving here and there. One is moving in this direction and another is moving opposite direction. So that is the reason the net flow of electrons in this conductor is 0. Suppose if the electric field is present, suppose one end it is there and another. If the electric field is there, then the net flow of electrons are moving opposite to the direction of this electric field. If the electric field is there in this direction, then the net flow of electrons will be passing opposite to the direction of applied electric field. So once again, this electric current must be passing through these conductors, solids, liquids and gases. In solids, electrons, free electrons are responsible. Whereas liquids, ions are responsible, positive ions and negative ions. Whereas gases are concerned, only ions are responsible. Suppose if a conductor is placed inside the electric field, there is no electric field, then the net flow of electrons will be zero, because all the electrons are moving randomly because of the thermal motion, thermal energy. They are moving randomly in all directions. That is the reason the net flow will be zero. In the presence of electric field, these electrons will be moving opposite to the direction of applied electric field. Now, after this one, we will see one important principle, namely Ohm's law. What is Ohm's law? The current passing through the conductor is directly proportional to potential difference developed across its end of the conductor. That means the relation between V and I are directly proportional. Once again, the current or potential difference across the conductor is directly proportional to its current passing through the conductor. V proportional to I or I proportional to V. Now, if I am removing this proportionality constant, I can get one constant. This R proportionality constant, we call it as a resistance. Then what is the resistance? It is the ratio of potential difference to the current passing through the conductor. That ratio, we call it as a resistance. What are the units of resistance? Its SI unit is ohm. Symbolically, you can represent like this. Symbolically, SI units of resistance is ohm. Now, define ohm. If the current passing through the conductor is 1 ampere, to develop a potential difference of 1 volt, then that resistance is said to be 1 volt. Once again, we'll see the definition of Ohm's law and we'll see the definition of resistance and its SI unit. The potential difference across the conductor is directly proportional to current passing through the conductor. That is V proportional to I. If you remove that proportionality, you will get one constant. That constant is R. That R, the proportionality constant, we call it as a resistance. What is the resistance? Define resistance. It is the ratio of potential difference across the conductor to the current passing through the conductor. So that ratio, we call it as a resistance. What is its unit? Its SI unit is ohm, and symbol is, you see on the board there is ohm. And what is the defined 1 ohm? Say, if 1 ampere of current is passing through the conductor, to develop a potential difference of 1 volt, then the resistance is said to be 1 ohm. Later, we'll see the factors on which resistance depends. See, resistance is directly proportional to length. Resistance is inversely proportional to area of cross section. Resistance is directly proportional to its length and inversely proportional to area of cross section. By combining all these things, we can get R proportional to L by A. If I am removing the proportionality, then once again you can see R is equal to rho L by A. R is equal to rho L by A. Once again, resistance is directly proportional to length. Resistance is inversely proportional to area of cross section. By combining these three things, we can get R proportional to L by A. If I am removing that proportionality, we can get R is equal to rho L by A. What is this rho? This rho we call it as a resistivity, or we can call it as a specific resistance. Now, how this resistivity depends? This resistivity depends on nature of the material and temperature of the material. It is independent of dimensions of the material resistivity. Now, the total lesson, now once again, what we learned, now once again, we can recollect all those things from this today's lesson. See, what is the main difference between electrostatic and current density? If you study the charges are at rest, that we call it as electrostatics. If the charges are in motion, that is current density. Now, what is the meaning of electric current? Electric current is nothing but ratio of charge to the time. That means I is equal to Q by T. All this electric current is passing through the conductors, because in solids, electrons or free electrons are responsible, and in liquids, positive and negative ions are responsible, and in gases, again ions are responsible. Then what is the meaning of Ohm's law? The potential difference across the conductor is directly proportional to electric current passing through the conductor. That is, V is equal to IR. That R is called constant of proportionality, that we call it as a resistance. And we already know the resistance unit is Ohm. Next, name the factors on which resistance depends. Resistance is directly proportional to length. Resistance is inversely proportional to area cross section, and R is equal to L by A. If I am removing this proportionality, we can get R is equal to rho